We just saw how to deal with compound inequalities that represent intersections. I do want to show you how to solve a three-part inequality. So I showed you how to represent your answer as a three-part inequality, but now I want you to see how to solve one. So just as an example, if I were to set up an inequality like -7 is less than 5x minus 2, which is less than or equal to, let's say, maybe 23, something like this. We could solve this inequality. Again, it is a three-part inequality. It does have a interesting algebraic expression in the middle with numbers on the ends. Basically, we're saying that -7 is less than this quantity, which is also less than or equal to 23. And so to solve, I want to get x in the middle by itself. One rule of three-part inequalities is that whatever you do to one part, you must do to all of the parts, okay? Because remember, essentially we're solving two inequalities at the same time. It would be equivalent to solving -7 less than 5x minus 2 and 5x minus 2 is less than or equal to 23. So we're solving both at the same time and looking at their overlap or their intersection. Okay, so the three-part inequality is essentially the same thing. So here, to solve for x in the middle, I would add the 2. When I add the 2 to the middle, I need to do that to both the left and the right side also. Whatever you do to one part, you must do to the other two. Okay, so I add 2 to all three parts. This gives me a -5 is less than 5x, which is less than or equal to 25. Then I can divide out by the 5, but if I do that in the middle, I must also do that on the ends. Another thing to keep in mind is that if you had to divide by a negative here, which is sometimes the case, you would need to interchange both of the negative or the inequality symbols to greater thans. Okay, so you'd have to switch them around. But here I'm dividing, what am I doing here? Here I should be dividing by a positive on all three, and so we don't have to worry about that. So I divide out by the +5. Here I get -1 is less than x, which is less than or equal to 5. Okay, so my solution then, the overlap, is just this interval. And I don't actually have to worry about solving them individually and then looking at the overlap of their intervals. All I really have to do is solve it once, and then the overlap is already done for us, essentially. Okay, so now all I have to do is put this in interval form, -1 to 5, using a parenthesis on the -1 or bracket on the 5. And of course, if I wanted to put this in set form, I could, simply by just taking this compound inequality and putting it in the right side of the set builder notation. So either of these answers is correct. I believe my math lab is most often going to use the interval form, but you might also see the set builder form show up from time to time. Okay. Okay. So that's how to solve a three-part inequality. They're fairly simple. They're a little bit easier than solving them individually and looking at the overlap. Okay. They only work, however, if you have the same expression for x in both inequalities. Otherwise, if I had a 5x minus 2 and a 13x plus 7 here, I wouldn't be able to do the overlap. I wouldn't be able to do the three-part inequality because I have a different expression for x in each inequality. So here I have the same expression, so I can go ahead and do that. Okay. Now let's take a look at unions. So we talked about intervals, and now unions are where we look at any element of one set or the other, or both. They can be in any of them. Okay, so a union, the union of two sets is any element of one set or the other, or both. Okay, so it doesn't actually matter. It could be in one, it could be the other, or it could be both. And so the union, unions are usually bigger than individual sets, whereas the intersection is usually smaller, okay? So a union, you might say, a union, the symbol for a union is a U. Remember, the intersection was an upside down U, like a rainbow. The union is the U itself, which makes sense, it's a union, U and U, right? So that's a little bit easier to remember. If I wanted to take, let's say I want set A, we'll look at the example I did in a previous video where we dealt with set A to be all the even integers and set B to be all of the integers from 0 to 9. I can't count. There we go, 3, 4, 5, 6, 7, 8, 9, or what we would call the 10 digits, right? Those are the 10 digits. The union then, A union B, is all of the even integers, and then we also would be including 1, 3, 5, 7, and 9, right? Because that 1, 3, 5, 7, and 9 are in one set but not the other. So if I take the larger set, include that, and then pull out all the extra numbers from the other one, that should give us the union. So I would probably write this out. Now it's a little bit tricky to write all of this out. I'd probably just write out all of the even integer notation here first. Okay, so that gives me it's a representation of all the even integers. We've got the dot 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 on the left and the dot 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 on the right, so you can show that it goes indefinitely. But then I'd also put at the end of this the extra points, which are 1, 3, 5, 7, and 9. So 1, 3, 5, 7, and 9. Now this maybe isn't the most formal or mathematically accurate way to represent it, because usually when we put the dot 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 in there, we don't start again with another pattern or another set of numbers, but I'm going to in this case because it's the quickest way to represent that, and you guys are going to know what I'm talking about. Okay, so that's the union in this case. We deal with intervals, we can also do unions of intervals. So if I were to take something like the interval A to be all the points, let's say anything from 3 to infinity, and let's say interval B is anything from negative infinity up to negative 5. Maybe I won't include the negative 5 there. So let's say I had those two intervals. Well, on a number line, the two endpoints are negative 5 and 3, and then of course the infinities. And so on the first one here, 3 to infinity, well, I'll do these separate again. Starts at 3, goes off to the right, includes a bracket on the 3. Negative infinity to negative 5, we could start at the negative 5 and go left to infinity, putting a parenthesis on the negative 5. The union is any number that's in one or the other or both. Well, there's nothing in both. There's no overlap or intersection here, but that's okay. I still have numbers that are in one or the other. Okay, so in this case, the union is everything to the left of negative 5. Okay, not including the negative 5. That one's not in there. It's also not in here. Okay, it's a negative 5 is in neither set, so I can't include it. 3 is in the first interval, so I'm going to use that one. And so is everything to the right of 3. Okay, and so these two together make the union, and so I would write them in one set, or one interval, from negative infinity to negative 5, and then I would say union, that negative 5 should not be included, that should be a parenthesis. it's a union from 3 to infinity. Now that looks kind of silly because at the end of the day, it's just these two intervals written in with the union in between them. But that's all you really have to do on this one, is write it that way. Sometimes when there's an overlap or something, we'll be able to write it in a simpler way. Let me give you a real quick example like that. Something like, if my interval A was from -2 to infinity, interval B was from -5 to 7, something like that. Okay, so here, when I look at my overlap, or not my overlap, but my sets, my two sets, and then try to take their union, -2, -5, and 7 are all different endpoints. Oops. So -5 is farthest left, -2 is next, 7 is out here on the right. Okay, I'm not putting these all to scale, I'm just trying to get them in order on the number line. And then I shade in, so -2 to infinity starts at -2, goes to the right with a parenthesis. -5 to 7 has a parenthesis on -5, goes up to 7, and then has a bracket. Numbers that are included in one or the other or both. Well, there are some in both. There are some in one and not the other, and some in the first and not the second. So we've got all those options to sort through, but really, as long as a number shows up in one of those two sets, it's in the final answer. And so certainly, -5 itself is not. It's not in either one. Things to the left of -5 also are not. When you move to the right, pretty much everything after that is in one of the two sets, or both, okay? -2 is in one of the sets, 7 is in both of them, numbers in between are in both of them, and so I'm just going to be able to actually shade all the way to the right, all the way out to infinity, so including the arrow. Okay, so the final union of these two sets, A union B, is this final shaded interval from -5 to infinity. And so it looks a lot simpler in this format than it did in the original. Okay, so it works out kind of nicely. Now, with unions, we typically use the word or instead of and. Okay, so or represents unions, all right, rather than and was intersections. And so with unions, the problem with unions is we can't just combine them into a three-part inequality like we could with the ands or the intersections. The unions must be kept separate. And if I were to solve a union problem, it might look something like 3x minus 9 greater than or equal to -21, and -x plus 4 is greater than maybe 18, and I don't know, we'll see what happens here. So on this one, and then let's throw the word or in the middle. All right, so I'm looking for the union of these two, one or the other or both. And so I'm going to add the 9. Now this one I have to solve each of these individually. 3x greater than or equal to -12. Divide by the 3. X is greater than or equal to -4. And over here on the right, subtract the 4. -x is greater than 14. Divide by -1. Got to switch the inequality when we divide by a negative, and I get x is less than -14. So the final union can be found by plotting a graph. Let's actually make that look a little more horizontal. There we go. -4 and -14 are the two numbers on the graph. Always want to put them in the order they would appear on a number line, so -14 is on the left. This one, x is greater than or equal to -4 gonna be all the numbers to the right there. X is less than negative 14 would be numbers to the left. There is no overlap, so there's not really a nice way to represent this any shorter. I literally can just take the two intervals, put them together with a union symbol in between. And so the final answer would be negative infinity to negative 14, union negative 4 to infinity. Okay. Again, I believe my math lab will prefer this interval form. If you needed a set builder form for this, you could also do that. It is a little bit lengthy to write out. You would write x such that, and then you would have to put both of these inequalities with the word or in between. So you could say x is greater than or equal to negative 4, or x is less than negative 14. Okay, so there's not really a nice succinct way like there was for intersections to represent those.